Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied about what is valence, as well as we have also got to know that how the valency changes. That is, we have also understood that what are the trends of valence in periodic table. So now we are going to study about what is oxidation state and what are the variations that we could see in the periodic table. So let us check it out. So now we are going to do the study of what is actually oxidation state. So what is oxidation state actually? Oxidation state of an element in a particular compound can be defined as the charge acquired by its atom on the basis of electronegativity of the other atom in the molecule through which it has been attached. For example, what does it say? Suppose we know that whenever we are talking about a covalent bond or a molecule, for example, in this case I will consider the example of, again I could take the example of HCl also, but suppose let me take the example of KCl. So this KCl is a molecule that is composed of potassium as well as the chlorine atom, as we know. So this molecule basically consists of the potassium, which has basically partially positive charge, while that of the chlorine atom, which has partially negative charge. So this partially negative charge that makes the oxidation of the chlorine to be, as we can also state that the oxidation state of the chlorine atom in this molecule will be -1. So if the oxidation state of the chlorine is -1, then the oxidation state of the potassium will be +1, because it will be the charge acquired by the atom when the other molecule is also attached to it, and based on the charge that it acquires for the potassium, it will depend on the atom which is been attached to it. So in this case, the potassium is an atom which is been attached or which is been bonded with the chlorine atom, as well as we know that the chlorine is more electronegative. So what will happen, that the chlorine will pull the electron towards itself whenever we are talking about a covalent bond. So what will happen is chlorine will now be more electronegative than compared to that of the potassium. So that makes the potassium to have a positive charge. So therefore this positive charge that we compare with a positive charge atom and a partially negative charge atom will make a rise in oxidation state, and hence the potassium will have the oxidation state of +1. So this is how we could differentiate that what is oxidation state. It is very easy to understand, but this was a molecule which consists of two atoms, but there will be also a few atoms that we know that consist of more than two atoms, basically 3 atoms or 4 atoms. So let us talk about that also. But for that instance, let me give you an example and let us see that what will be the oxidation state of these atoms that are being present in the molecule. For example, if we are talking about this molecule, that is oxygen difluoride. So in this case, basically the oxygen is being only 1 times, while that of the fluorine is being repeated 2 times. So in this case, the bond can be written as we know that the valency of the oxygen is 2. So that means we could write this molecular formula, that is, or basically we could say it as the molecule that has been present in front of us. So we could write this thing as in this manner also. It's very easy to represent in a structural formula. So as we could see that the fluorine is been attached to oxygen, and again this oxygen is been attached to the fluorine, and moreover we know that oxygen is electronegative, as well as the fluorine is also electronegative atom. So in spite of having these two are electronegative, but how can we say that what would be the oxidation state of a particular atom like fluorine in this case? So for that instance, we know that fluorine is the most electronegative atom of the whole periodic table when it comes to the element. So therefore it makes the fluorine to have basically partially negative charge. So in this case, the fluorine atom will have partially negative charge. So this will make us to understand that the fluorine atom will acquire or will try to pull the electrons of oxygen also towards itself. So this electron of oxygen will be pulled towards the fluorine, as well as this electron of the oxygen, because a bond is made up of 2 electrons at least. So in this case, as we know that in this case what happens is electron is being pulled by this fluorine. So this pulling of electrons of the fluorine, because the fluorine is the most electron negative atom, or we could say in the periodic table, so that will make an influence that the oxygen being the electronegative also, but it is less electronegative than that of fluorine. So now in this case, this will acquire partially positive charge. So in that manner, we could say that the oxidation number of fluorine is always -1. So therefore, in this case, the oxidation state of fluorine is -1. But in this case, oxygen, as we know that oxygen has a valency of 2, and when it comes to the charge, it acquires -2 charge. But in this case, basically in this example, since oxygen is behaving as a partially positive charge, so in this case, because it is also been attached to 2 fluorines, so therefore in this case the oxidation number or the oxidation state of the oxygen will be said to be +2. So therefore the oxidation state of oxygen is +2. So this oxygen is now +2, while each fluorine atom that have been present in this molecule is -1. So basically this will overall make the species or overall make the molecule to be electrically neutral, because the oxidation number will cancel out each other. But when we are talking about the individual, that is when we are talking about the oxidation state, and as we know that the oxidation state will depend on the electronegativity of the other atom also. So now in this case, because oxygen was said to be basically an electronegative atom, but because it has been attached to fluorine, which is more electronegative, now it has acquired a partially positive charge, which makes the oxidation state of the oxygen to be +2 in this case. But in case of H2, we know that the hydrogen is more electropositive, while that of the oxygen is more electronegative. So in that case, that is in H2O, that we know that most of the molecules that we know in which the oxygen acquires -2 charge or partially negative charge when it has been in a combined state to form a molecule. So therefore, oxygen in H2O will have -2 as the oxidation state, while the hydrogen will have +1 as the oxidation state. But in this case, it is quite different. So that's the reason that we should understand that what is oxidation state. So therefore we have understood that concept also. So now let us learn another concept in which it would be very much easy to understand. For example, in this case, that is Na2O, that is disodium oxygen, or we could say sodium oxide. So in this case, basically what we could say that in Na2O, that is disodium oxide, in which we could write the structural formula like this one. So this sodium oxide basically, and in this case it consists of 2 sodiums and 1 oxygen, and moreover we know that oxygen is the one which belongs to the P block, and basically we know that it is electronegative compared to that of the sodium, and sodium is belonging to S block, and S blocks are and S block consists of the elements which are basically electropositive or which has the tendency to lose electron. So that in the case, if sodium is losing electron, so therefore it will acquire positive charge, partially positive charge in this case. So meanwhile, that electron will be pushed towards the oxygen in this case, and oxygen will be more electronegative, because it is actually electronegative, but now because of the sodium, it will be more electronegative. So now what will happen? So the oxidation state of sodium in this case, because it has been repelling its electron, or it has been donating its electron mostly towards the oxygen when it is combined in a molecular form. So therefore the oxidation number, or the oxidation state, if I would say more precisely, that the oxidation state So now, therefore, for sodium, we could say that the oxidation state of sodium is +1. So for both the sodiums, means for each sodium, the oxidation state would be +1. So as to compensate this thing, a negative charge has been required. Or moreover, we could say that because of oxygen, which is more electronegative than compared to that of the sodium. So now, when we are talking about the oxygen's oxidation state, so therefore, the oxidation state of oxygen is -2. So this will be having an oxidation state of -2, while sodium will have oxidation state of +1. So now, in this case, they are now being compensating each other when it comes to the charge or oxidation state. So in this case, basically the whole molecule is now being neutral, and we could say that this is what the valency is also being showcased in this case, because as we know that the oxidation state of the oxygen is -2. That means it can form two bonds with a univalent atom. So therefore, in this case, basically oxygen is being attached to two univalent atoms, mainly sodium. In the previous example also that we have took the example of that is F2O, and in that case, what we have got to know again, oxygen is the one which is forming two bonds with univalent atoms like fluorine. So therefore, that is, in that case also we have got to know that the valency of the oxygen is 2. But and also in case of the fluorine, we have got to know that its valency is 1. So this is how we could understand oxidation state, a very easy concept. And talking about the oxidation state, this oxidation state of the oxygen, sodium and fluorine, they are being fixed, or it depends that to which it has been attached. But there are certain elements in the periodic table which don't have a specific oxidation state. For example, if we are talking about D block elements, or basically they are known as transition metals or transition elements, these elements have the tendency to lose electron. They can lose 1 electron, they can lose 2 electrons, means depending on the electropositivity or oxidation state, their oxidation number changes or oxidation state changes. For example, Fe, that is iron. Iron, when forms in a Fe2 plus oxidation state of iron, if suppose it is +2, then that is known as ferrous. While if the oxidation number of the iron, it is suppose +3, then it is known as ferric. So basically the oxidation state of the iron also changes. While that of when we and depending on that to which atom it has been attached to, and depending on that, all the D block elements has a capacity to show different oxidation state, most of all. And talking about the F block elements basically known as lanthanides and actinides, even they have the tendency to show variable oxidation state. So when we move from lanthanum to the last element of the F block, so we could see that the oxidation number varies, and while that of similarly we could see the change or the trend. It could be observed for actinide also, because the oxidation state of the metals also changes depending on with whom it is being with which atom it is being attached to. By talking about the oxidation state of the S block, continuation. While talking about the oxidation state of the S block, like the first group and the second group, the oxidation state of the first group, that is when it starts from the lithium to francium. So the oxidation state of those elements stays +1 only. While that of the group second elements, like from beryllium, so the whole group elements have the oxidation state of +2. So this is the variation that we could see. And when it comes to this is what we have talked about the group, and when we go to across the period, then even that also we could see that there would be variations in oxidation number, because as we have talked about lithium, so lithium has an oxidation number of +1, but while that of the beryllium, it is +2, and it will go on just like the valency that we have did in our previous lecture. So it is very simple to understand that what is oxidation state, and moreover in this case we have got to know that it depends on the that is electronegativity of other compound, while valency is the one that we have studied, that it depends on the number of electrons that are present in the outermost shell, and because of which it also changes when we go across the group, or when we see the variations in the periodic table across the group. So was a very simple topic that I have shared with you. So thank you friends for watching this video. I hope you have liked this video and you have understood the concept of oxidation state, and you will share this video with your friends. And yes, don't forget to subscribe to Ekeeda channel. Thank you so much.